Yeah, so welcome to our prototype crash course. I assume that most of you are here so that you have some ideas on how to prototype your product for Startup Week itself. But even if you're not, there's a lot of good information you can get out of this. So one thing for sure, well, two disclaimers. The first one is it was not a typo to see that this was 30 minutes long. It's really hard to kind of do a crash course on software development or hardware development and 3D modeling or how to design something. That would probably take 6 hours or more. And I don't think anyone wants to be bogged down in that, especially managers, us as managers. So that's why we're going to do this short session to like show you the tools you can use and just a quick crash course on the design thinking process, because that's very important for designing any product for your customer. And yeah, I think we can get started now. If you could go to the next slide, Summit. So yeah, Startup Week is this week. There's still time to submit up until Friday at 6 p.m. So if you have a team, there's still time, no pressure. But if you don't have a team and you're very interested in meeting with, let me make sure everyone's muted first. I just made that. Okay. Okay, so back to the presentation. As I was saying, if you are really interested in participating with a team, let us know and we can try and set you up with someone random, because there are a lot of people on the interest form that are interested, but they aren't really competing because they don't have the team members they might want. So I will also put in the chat our email address if you would like that to happen, and I'll also link the website at the end. And then now we have our manager, Jovan, introducing what the Startup Center is.
All right, cool. So basically we are, if you're not familiar, we are the Student Startup Center. Basically our mission is to help all UC Davis students start their ventures. So their ventures could be anything from from just learning about startups if you know nothing about entrepreneurship and you want to learn more, or if you have an idea and you just want just something to help kickstart your idea. We have resources to help with that as well. So some of the things we offer are classes on entrepreneurship and launching a business that you can take for credit. And that also leads into a certificate of entrepreneurship that we offer. And then we also have a makerspace, and that's free for all students to use, as well as workshops to teach you how to use all of our machines, and as well as teaching you skills that some non-technical skills, more essential skills, such as business development or interview techniques, stuff like that. And there's also a lot of other discussion style events for you to just learn more about the startup world, talk to mentors who come, and accelerators like Plasma. All right, so we'll go into what is prototyping. So prototyping is just the process of taking an idea and making it into a working product. So usually when you're prototyping, you're addressing a challenge or you're trying to solve a problem. And this process is kind of how you go about trying to solve that problem rather than just kind of fumbling around blindly. So there's these 6 steps. So we start off with empathizing. So you see here, it's understanding a deep understanding of the challenge. And it's also understanding the audience or your client, basically who is going to use whatever it is you're making, and kind of understanding where they come from and what their situation is like. Next is define. Now that you sort of understand the challenge, you have to kind of put some constraints on yourself, knowing what are the limitations of what it is you're working with, what exactly your product needs to fulfill, and kind of stuff like that, like space limitations if you're making a physical product, or I don't know, memory specifications if you're writing software for something like that. And then the next is kind of the fun part, ideate. And that's where you actually, use your creativity and come up with potential solutions, come up with potential ideas for things that might solve your problem or address your challenge. And then you go into prototyping, and that's when you actually take those ideas, and you should have a lot of them, and try to narrow down on a couple of them to try to actually make into a product, and trying to actually create that actual solution, that actual product. And then the point of prototyping. So the last two steps kind of go hand in hand. Prototyping and testing is very important because you have to test your prototype to make sure that it works, and also to narrow in on some problems that your prototype might have. And once you test it, you can go back and make another prototype and hopefully solve those problems as well. And then the design thinking process is not a linear process. So you have to go back and forth between all these different steps. So like, let's say, so the most obvious one is if you test your prototype and one part of it doesn't work, you can go back and ideate a new solution and create a new prototype, and then test it to see if that problem has been solved. But then you could also need to redefine your problem if your problem turns out to be not specific enough or kind of misguided in some way. And you might also need to reconsider who like your customer is or who your client is, because that might change as the process goes on. So next we'll have Rashida and Miko talk about the software prototyping process.
Cool, yeah. So like Johan talked about, it's extremely important for people to understand the importance of doing customer research. So the reason I'm saying this is because technical development can be very hefty, particularly software development. If you need cloud storage, if you need to pay for servers, and so you need to understand who you're targeting and why you're targeting these people with your product. So an example is actually a project I've done in the past with a couple of other people, and it was to address food insecurity within California. So as you can see here, I highlighted some of the key points. 42% of students in the UC system struggle with food insecurity. We surveyed students, and they showed that they're just as likely to share deals as they're to find deals. Initially, we wanted to actually have this be on Yelp because Yelp is like a dining associated mobile app and web app, but we actually found out after doing customer research or possible customer research that most people actually find their information Facebook or Instagram stories. So it saves time and effort. It saves money. Time is money, but also it actually saves you money. And it really encourages you to understand how it works from the customer's perspective and, step in the other person's shoes without just leaping into the product or the development. Can we move on to the next slide, Summit? Thank you. So there are different levels of fidelity in prototyping an idea. So this is, within the ideate portion of the design process that Jovan had shown earlier, the 6-step process. And essentially a low fidelity way of representing the idea is even using paper. So here is a low fidelity way of representing the idea that we had. So Facebook Pantry would be just an extension or another feature of Facebook, just like Marketplace says. So we, drew it out, we talked about it, and we didn't even touch any code. We just showed this to people, asked them what they thought about it. And then after we did that, we could make improvements really easily, really easy to refine the idea, you know, when there aren't like multiple factors involved. So this is the next step of Fidelity. So, you know, once you do it on paper, you you get an idea, you do some customer research, you iterate with the paper, then you can move on to, you know, this higher fidelity prototype that can be done on a design prototyping school tool such as Envision. So here you can see that we developed this with Envision. Envision, again, is a design prototyping tool. And you see here, this is Pantry. So Pantry will offer student or people the ability to view a community forum with discussions about deals. It will help them share deals. So, you know, our tasks for users were to essentially like navigate the feature, try to share a deal, and we found that, you know, there was some confusion, so then we even added like a tutorial, so that's not included in this video, but we actually had another Envision prototype in which we added on a tutorial too. And feel free to ask any questions if you want.
Yeah, so as managers, we really encourage and promote the idea of prototyping without going out of your way to build something with code. Because as much as we like to jump into a project and it's really exciting and fun, it's also really important to consider the time and effort you're going to be putting into that project before you've even tested it out on a customer. So yeah, here are some resources of ways you can build out your potential website, app, or anything software based without using code. So if you're essentially wanting to build a website, for example, there's WordPress, there's Wix, there's Squarespace. I'm sure you've seen all the YouTube advertisements for them. They're all free trials, and that's all you really need to get started. You don't need to buy a premium subscription to build a website because most of it is free. But if you're more interested in the design aspect of things, in which you can have cool ways to prototype and test it out as if there was actually code, there are really nice and free options such as Figma and Envision, in which there's usually a student discount. I know for Figma for sure there's 100% a student discount to use like the pro version of it, so I highly recommend it. But if you want to do like a free trial and maybe spend some money, that's when Sketch and Adobe XD would be some other good options as well. And in the competition packet that is also listed on the website, we have literally most of these on the packet, along with a few others, such as bubble.com. I highly recommend that one because you can literally make Facebook or Yelp maybe within an hour or two just by dragging and dropping things. So to finish with software, again, we promote not using code just yet before you test out with customers. And Harshita, before we jump into hardware, did you maybe want to share the design app you worked on with the clothing, or did you want to save that for the end? You muted yourself.
Thank you. Yeah, I can show it at the end.
Okay, just to give you more time to prep.
Yeah, thank you. You gotta pull it up. Thank you.
Cool. So hardware prototyping focuses more on the latter half of the design thinking process, which is ideate, prototype, and test. Since you need a physical MVP to test your hardware, you're gonna start with ideating, where you write down what you want in this first MVP, and then you're gonna prototype that initial version. You'll test it, see what works, see what doesn't work, and then you can jump back to ideate and kind of loop through these processes until you have a final version that you kind of refine through testing, through giving your friends, letting people like play with it hands-on, so you can see what it's like in the hands of users rather than just you like putting it together and then knowing how to use it. You can just test it. You want to give it out to someone else so they can experience it and see if there's anything that's not intuitive about how it's used and things like that. You're going to want to efficiently organize your process so you save time and effort, and that'll result in a better product. So in this graph about time management and prototyping, you can see that you should do all of the hardest tasks at the beginning, and then at the end, just like fix small bugs, like scale to a bigger version, or just do the aesthetics, rather than scoping and like doing the easy stuff at the beginning and then sprinting to do the big challenges at the end. This way you can really not worry before the ship date. You're getting the hardest tasks done, and then you're kind of going into the ship date with an almost complete product rather than scrambling at the finish line. So you can use short cycle prototyping so you can test quickly, and then you can quickly identify the most critical parts of the design that's important. So you easily identify the most important parts, and those are the things you fix early on in the beginning. So you're not like 2 days before you have to turn in this project and you identify like this giant problem that's going to take a few days to fix. And going from there, your first prototype is also the one that's going to be the roughest and like the least aesthetically pleasing. It's going to be more of a proof of concept, so you can test if it functions like you want it to. And then once you've used that first prototype to refine the core functions of your design, then you can, like I said at the end, deal with aesthetics, UI, UX, and other small bugs that are easier to tackle in shorter periods of time. And the first step, ideation, is a real key component to this prototyping process. You're going to want to research and look at what's already been done, and then try and come up with a bunch of quick designs so you can compare all of them, identify shortcomings for each one, and then decide on the most promising design that you want to move forward with. So like sketches are great. Just get a piece of paper or a notebook and just fill it with all of your sketches, and then think about it, compare all of them together, then come back later and choose the best design that you want to move forward with, or even if come up with a new design that incorporates the best features of all of the other ones you've come up with. And then after you have your first design from your sketches, you're going to want to make your first prototype. And this is going to be made from something that you can work with easily and quickly. 3D printing is good for rapid prototyping, but it's easy to get lost in like designing and modeling and things like that. Something that's a little bit quicker for you to use your hands to get a really easy, quick proof of concept, like paper, cardboard, Lego, duct tape, plywood. Something that's like accessible and you don't have to like go out to the store and buy it. This picture on the right is from a student in engineering 3. They actually wanted to prototype their carrot sorting machine. So they use a small scale cardboard version. You can see this is like the intake for the carrots to drop into. Here, this piece of cardboard represents an ultrasonic sensor that'll detect like the distance between the sensor and the carrot, and then subtracting that from the known distance between the sensor and the track, they can get the thickness of the carrot. And based off like a threshold of thickness, this flap will move with a servo, so it can direct the carrot into either of these two other channels so they can be sorted by size.
All right, cool. So your first prototype, right? Your first prototypes are proofs of concepts. So they shouldn't be anything even close to what you envision your product to look like, or to maybe even perform. But it's to test out some of the key features of your product, the key functions of your product. So also, if you're using some outsourced products or outsourced components, you might want to test those to make sure that they work how you expect them to. So basically, for this first prototype, you want to strip the design down to its absolutely basic functions. So for example, if it's a mechanical design, you want to try to just recreate the basic motion, basic dynamics. If it's like an electrical design, you might want to first make like a breadboard circuit and test it and make sure that the circuit works as you expect it to, as you designed it. So here I have a couple of examples. These are both from YouTuber and engineer Mark Rober. So in this first one, this is his first prototype of a kind of a rocket-powered golf club. As you can see here, it does not look functional at all. Like the rods are completely thin. You could see it bending. it doesn't even look very stable. But that's not the point of this prototype. This point of this prototype is just to see if just how the rocket works and how the rocket works with the type of motion that he wants to have, which is this sort of like spinning motion. And from there, he was able to see just sort of what kind of speeds the rocket is able to provide, as well as like seeing, okay, like from there you can start tackling other problems such as, okay, now I need to thicken this rod or make the base more stable, stuff like that. On the bottom here, you see the first prototype of his snowball machine gun, basically. So all he did here was he bought a PVC pipe from like Home Depot or Lowe's or something, and stuck it on the end of his leaf blower, and just threw a snowball in there just to see if just the idea itself worked. Whether or not the leaf blower would have enough power to even propel the snowball, if it flies straight, if the snowball like would kind of disintegrate inside the tube, stuff like that. All these like key issues were kind of brought to light just from this first prototype. You can see that, okay, it works. I can move on to actually making it more easy to use, making it be able to shoot multiple snowballs at once, stuff like that. Okay, there we go. Oops. Okay, so once you've made that first prototype and your proof of concept works, you can then start to further refine that prototype. So this is where you start going into CAD and modeling it, and then maybe 3D printing it, incorporating more electronics and more software, some like sensors or stuff like that if your product needs it. And like Sumit said before, you want to tackle the largest problems first. And that's something that we're going to keep repeating like throughout, is tackle the largest problems first, because you don't want to try to solve these problems when you have a deadline coming up. Another thing is you want to try to make your prototypes easy to configure and change. So that way you can use one prototype to test a whole bunch of different ideas. And this is completely different from that first prototype where you're just testing like the key components. This way, this is more for like fine tuning. If you have some very small parameters that you need to change, such as like, I'll go into it in these examples. So in this one, this is again from Mark Rober, and this is his rock skipping robot. And he's made this robot so that everything is sort of configurable. So he's trying to figure out what the best launch angle and best like rock angle, best launch speed, force, etc., to skip a rock. And he's made this arm basically adjustable, so he's able to fine-tune each of those variables without having to make a new prototype for every change. And that will help to kind of streamline your prototyping process as well, because once you've kind of narrowed down on those variables, you can create a completely new prototype that tests a whole bunch of other variables. So on the bottom here is actually one of my projects from a few years ago. I wanted to design, I think the goal of this is to design a catapult that is able to launch a ping pong ball a very specific distance and land in a cup. And so I didn't know how much power or the launch angle, or I don't really know catapult physics too well, but what I was able to do is I was able to make this catapult adjustable. So you see, I don't know if you can make this out, but there's these notches on the side of the catapult, and I can change sort of where I place this cardboard slot to change the launch angle. And also I can change the tension of the rubber band by sort of just twisting it more or less, and that will adjust the power. And this way I'm able to kind of fine tune the the trajectory of the catapult without having to make a completely new catapult every time. So yeah, basically capital largest problems first, and try to, for fine tuning, try to make your prototypes configurable.
Cool. So yeah, in summary, whether you're prototyping your product for hardware or software, they both really follow the design thinking process. And kind of to go back to Jovan's point, that is summarized a little bit differently of like solving the biggest problems. A way I would rephrase it is to solve your customers' main problems. Of like, obviously, when you start up a business or anything, you can't solve everyone's problems. That's just not going to happen. So it's good to focus on your customers' main problems and then build that solution into your prototype. And it's really important, especially for this competition, to improve your product based on iteration, not perfection. And there is no such thing as a perfect product, because almost everything we're using, Snapchat, Facebook, etc., it was not that many years ago when it first started out. It was probably really basic looking and used for user testing to iterate and build it to what it is today. So just keep that in mind of if your prototype looks really scrappy, whether it's cardboard, paper, whatever, that's totally fine. If your customer is into it, then keep doing that and iterate each time. And I covered that of tackling your customers' main problems first. And yeah, this is something for if you have extra time during the week, because I know people are joining this competition kind of late. But if you have time to test out your prototype, you can seek out your customers' opinions by, just asking family members if they're around, reaching out on LinkedIn, cold emailing, or just anybody you might know that meets your customer reach, I suppose. Even then, you still have family members to test it out, and any feedback is feedback you can work on. So yeah, I think before we go over the competition packet requirements, in which Dom is also here to aid me in, I will let Harshita share her prototype app that she made.
Cool. Yeah, let me share my screen.
I had a quick question.
Yeah.
So during this process, at the end of the week, when we submit, is there a Q&A that ends up occurring? What does post-submission look like?
So we've thought about this over the last week and a half, of like whether we wanted to have an award ceremony or to have teams pitch. And given such a short notice and just a lack of resources, given we're students doing this, we're just gonna post submission just looks like a shout out email about the winners or honorable mentions. Did I answer that right?
Perfect. Thank you.
Just making sure.
Cool. So this is a prototype I'd actually made last month. So I was interested in trying to develop something to help not eliminate, but help eliminate the fast fashion industry, and like how we could approach that. And I had this idea of having a closet where students could essentially have a peer-to-peer clothing rental service, particularly in college when so many things, there's so many social events going on. Something I would hear really often from my peers and friends would be like, oh, I'm just going to go to Forever 21 and get something, like, oh, I'm just going to go to so-and-so fast fashion, brand store and pick something up for the party. So it made me think of how we can be really conscious about, eliminating that. And so I developed this quick app prototype on Envision, which is what I talked about earlier. So, I click welcome, I log in, I can either take the tour or skip the tour. So now I'm going to skip the tour, and I can add to my closet. I can further develop it, but or I can show you what it would have been like to hold on, some technical difficulties. But you understand the main point. So it's just a really easy way of showing. Yeah, so like showing a person like a user flow, like asking them if it's user friendly, and just like getting quick feedback. So I actually wanted to apply to like an entrepreneurship track with this idea because I felt really passionately about it. But then I approached some of my friends, I had them try it out, and they brought up some really important points that I hadn't thought about, like in terms of like the revenue model, and like they actually even gave me ideas. So there is a lot of value in investing the time to do this versus just like installing Swift, like installing Xcode on your Mac and like coding up an iOS app, or like trying to develop the web app on your own, or whatever, in hardware too if you want to do it. Um, just like Summit was saying, or what Miko and I were saying. So yeah. Any questions?
Thanks for sharing, Harshita.
Yeah, no problem.
So we're just going to take a few short minutes to just go over what we would expect from an MVP prototype and the competition packet, and then we can leave it open for questions. So let me just see. Cool. So before I hand it over to Dom, given he made most of this, I will say that this portion, the prototype portion, even if you have a really great prototype, it looks amazing, you've tested out with customers, if it doesn't make sense with your business portion, then there's no point in this portion being scored. Because again, the prototype, if you do not have a good idea, because obviously it's 1 week, you don't have like something perfect and pinpointed. But if you don't have a good idea of who your customer is, what their problem is, or a potential solution, and that doesn't match what your prototype is trying to portray, then that's not really a great submission. But that's just my opinions on it, and I will kick it over to Dom for what he would look for in a prototype.
Yeah, thank you, Miko, and everyone else. Really great content and advice thus far. In terms of what I'm looking for from an MVP, I really stress the minimum part of the minimum viable product. It's the least amount of effort, or the smallest thing, or the roughest cut necessary in order to demonstrate to yourself, to customers, to potential investors, just to people, that your idea has merit, that it makes sense, that this could be a thing. So when we're talking about websites or apps, we often think of wireframes, or what Harshita was just showing us, and demonstrating that to a potential customer is a really good way of really directly showing that value. You don't necessarily have to have that sort of thing, though. You don't need to, if it doesn't make sense, you don't need to test something out with customers. For example, if you're developing an electric car, you're not going to want to spend the capital to develop a prototype if it's not going to work. But instead, we can look to other examples as examples of MVPs. So if I were Tesla back in the day, I might point to the Prius as an example of, say, hey, people want cars that are eco-friendly, and a fully electric car is just the next step in that process. And so that could be my MVP. That said, that kind of situation doesn't happen a lot, so we do hope to see something that you all develop. Yeah, and in terms of the video, again, I said in the information session, but I definitely recommend just doing something over Zoom, recording your call. That's plenty enough for us.
Cool. And I think with that, we'll leave it open to questions, and I will link some things in the chat. Yeah, so I've linked the website, which has the competition packet, basically outlining everything we kind of just described. And it has most of, if not all of the resources we listed here today. I've also added some YouTube videos for Figma and how to prototype something using cardboard. It's actually a pretty cool video. And there are some very short entry level videos of what it means to prototype and rapidly prototype. And yeah, this session will be recorded and that might be uploaded to YouTube within the next day, depending on if our manager is available to do it. So yeah, thanks for attending. If you want to stay for the next 10 minutes to ask any of us questions, both software, hardware, and both me and Dom, then we're here for the next 10 minutes. So thank you for attending.